morning, children. In today's class we are going to study some characteristic features of determinants, and two of these features are minors and cofactors. So let us see what exactly is a minor. Minor, because I said these are characteristic features of a determinant, so these minors are also real numbers, special real numbers. What is special about these? First of all, let's see that a minor is represented by capital letter M, written this way. So this represents, I represents the row number and J represents the column number. So when we write down Mij, we mean to say that this is basically minor of the element Aij of a given determinant, and this is actually equal to the determinant of Aij, which is represented like this. Alright, so let me explain this with an example. So let us take a determinant which is, say, represented as this. The determinant has got 9 elements, so minor of each element can be determined. So let us start with this, because this is element A11, so the corresponding minor would be M11, and this basically means that you have to find out the determinant of this element. How do we find out determinant of this element? By deleting the first row and the first column. What are we left with is these 4 numbers, so this is equal to determinant of 5, 6, 8, 9. On simplification, 45 minus 48, which is minus 3. Likewise, let us find out now minor of the element 1, 2. This is that element, because the element is present in first row, second column. So delete first row and the second column. The elements that we are left with are 4, 7, 6, 9, and this is 36 minus 42, which is minus 6. Likewise, we can find out minor of the element M13. So delete first row and third column and find out the determinant, which has elements 4, 5, 7, 8. This is 32 minus 35 equal to minus 3. So likewise, we have 6 more elements and we can find out the minors of all these elements. So this is that real number which is called the minor of which element? Of the element Aij. Alright, now next let us see what exactly are cofactors. Now cofactors, these are also real numbers. These are represented by Aij, or in some books they may be represented as Cij as well. Here I represents the row number and J is the column number. This is again basically representing cofactor of an element Aij of a given determinant. And this is because it is cofactor of this element. And how do we find out that cofactor? That cofactor is found as determinant of this element, and we represent it like this. The determinant is represented this way, but here you have to notice, for a cofactor it is simply not the determinant. The determinant is to be multiplied by minus 1 raised to power I plus j as well. So here the determinant is multiplied by minus 1 to the power I plus j. So in short, we can also write down that cofactor of any element is minus 1 to the power I plus j into Mij, where Mij is basically the minor of that corresponding element. So that means we are finding out minors and we are taking care of this concept here, which will give us the cofactor. So let us once again refer to this determinant only and let us find out here the cofactor of the first element. So the cofactor of the first element, here I is 1, j is 1, and the value of minor, which we have already calculated, is -3. So on simplification, this term is positive and the minor of the first element a11 is -3. Next, let's find out this, which is -1 to the power 1 plus 2, and this element is, minor is -6. This is also negative, so -1 multiplied by -6 gives us +6. Likewise, when we find out this, it is -1 raised to power 1 plus 3, and the corresponding minor is -3, which on simplification gives us -3. So here if you correlate, you will notice that M11 is same as A11. Similarly, M13 is same as A13, but M12 and A12 have different signs. So here what you notice basically here is, coming back to this determinant, first of all in this determinant I am going to circle all those elements where the sum of subscripts is odd. This element is A12, so 1 plus 2, 3. This element is A21, this element is A23, this element is A32. So these are the 4 elements, special elements. Why special? Because when you find out cofactors of these elements, the sign of the cofactor will be different from that of the minor. Like you can see this element, minor is -6. When you find out the cofactor has the opposite sign, that is +6. We can cross check for this case also. Let us find out for this case. The element here is in the third row and second column. Let's find out the minor. So the minor is, deleting the third row and the second column, the determinant is 1436, and this is equal to 6 minus 12, which is -6. Since minor is -6, so we know the cofactor will be +6, because this is a special element. For this element, if we find out the minor and the cofactor of this element will have exactly the same value with the same sign. So now the question is, what is the idea behind finding out minors and cofactors? First of all, minors help us to find out cofactors. Some elements do change their signs. Alright, what is the importance of finding out cofactors? Lot of importances. First of all, cofactors help us to find out the determinant. How does this help? Let us see this with an example. Let's take a determinant with these elements and evaluate it. Suppose we are evaluating it along the first row. So in the first row, we know this element will change its sign. So 1 multiplied by 1 minus 6, minus 2 into 2 minus 9, plus 3 into 4 minus 3. On simplification, minus 5 plus 14 plus 3 equal to 12. So we know the value of the determinant is 12. Right? Now let us find out here cofactors of the first row. Alright, so the cofactors are A11, A12 and A13. So finding out cofactors means delete the first row and first column, so the determinant that we obtain is this, which is 1 minus 6 equal to -5. When you find out cofactor of this, you know it will change its sign, because we have a factor like this, right? This into determinant of, deleting the first row and second column, we get determinant of 2, 3, 3, 1. So here you get a minus sign, and here 2 minus 9, so it is minus of -7. Alright. Then A13, deleting first row, third column. The determinant is 2, 1, 3, 2, which is 4 minus 3 equal to 1. Now please look at these numbers. Minus 5 is this value, alright. Minus of minus 7 is minus 7 here, and 1 is this element. So how do we correlate? What are these numbers? These are the elements of the first row. So the first element, writing down the determinant, this is the first element, which is A11, and A11 is multiplied by 1 minus 6, which is minus 5, and minus 5 is the cofactor of the element, this way. Then next element is positive 2 of the first row, and we are multiplying it by minus of minus 7. Minus of minus 7 is the cofactor of this element. So here the element is basically A12 multiplied by its cofactor. The next element of the row is A13, and 4 minus 3. 4 minus 3 is the cofactor of the corresponding element. So when we are basically finding out determinant here, what we are basically doing is, if we are expanding along the first row, we multiply elements of the first row by their corresponding cofactors. Okay, so here if we put the values, we can once again cross check that A11 is 1, this value is minus 5, A12 is positive 2, and this is plus 7, A13, the element is 3, and its cofactor we have found is 1. On simplification, minus 5 plus 14 plus 3, which is equal to 12. So here we notice that whenever the determinant is found this way, we can compare it as elements of, say, first row being multiplied by corresponding cofactors gives us the determinant. What happens if we multiply, say, row 1 elements by the cofactors of the second row? Then what will happen? So what I'm trying to find out here is elements of first row, which are these, and these elements are multiplied by cofactors of the second row, this. So here for convenience sake, let's find out the cofactors first. So this is minus 1 to the power 2 plus 1. Cofactor, when you find out cofactor of this, the sign will change, alright. So deleting the second row and the first column, we get elements 2, 2, 3, 1. So this is minus of 2 minus 6, which is positive 4. Next, let us find out A22, which is minus 1, 2 plus 2. This. Deleting second row, second column. The elements that we have here are this, which is 1 minus 9 equal to minus 8. And then calculating A23, minus 1 to the power 2 plus 3, and this. So deleting second row, third column, we have elements 1, 3, 2, 2. This gives us 2 minus 6, which is equal to positive 4. We have got the cofactors. Now let us find out the determinant. So the first element is 1 multiplied by 4. Next element is positive 2 multiplied by minus 8. Next element is 3 multiplied by 4. Simplification, 4 minus 16 plus 12, which gives us 0. So what we get to know here is that if the first row elements are multiplied by cofactors of any other row, then the determinant will always turn out to be 0. When can the determinant be correctly found? Only when the first row elements are multiplied by the corresponding cofactors. Likewise, when you expand a determinant along any column, say the second column, that means the second column elements have to be multiplied by their corresponding cofactors. Then we get the correct value of the determinant. If the second column elements are multiplied by, say, the cofactors of the third column, in that case, the determinant will turn out to be 0. So now we are going to write down this result in a generalized form. So next students, we'll take up some questions from the NCERT Exercise 4.4. So question number 1, a determinant is given. We are doing the second part of the first question. A determinant with elements A, B, C, D. So we are finding out here minors and cofactors of all the elements. So minors M11, M12, these are minors of the first row. Then minors of the second row M21, M22. Now for a 2 by 2 determinant, how do we find out this minor? First row and first column. First row, first column deleted, the element obtained is D. Right, the determinant of D will turn out to be the element itself. M12 delete first row, second column, the element is B. M21, so delete second row and the first column, the element is C. And for this deleting second row, second column, the element is A. Alright, minors obtained. Now to find out the corresponding cofactors. See which elements will change its sign. This element, because the sum of subscripts is odd, here the sum of subscripts is odd, so these two elements will change their signs. So minor M11D is also same as cofactor of the same element. Positive B will become negative B, positive C becomes negative C, and the minor of element A22 is A, and this will also be the cofactor. Alright, so finding out minors and cofactors of a 2 by 2 determinant is easy. Now next we move on to question number 2. Second question, we are doing the second part. A 3 by 3 determinant is given. First row elements 104, 3, 5 minus 1, 0, 1, 2. So 9 elements. Let us find out the minors first. M11, M12, M13. Then next M21, M22, M23, and then M31, M32, M33. So here we can directly find out the minors. So deleting first row, first column, we have here the determinant 10 plus 1, which is 11. M12 means deleting first row, second column, so we'll have 6. Then finding out determinant of this element M13, M13 means delete first row, third column, so we have determinant of this, which is equal to 3. Then M21 determinant means delete second row and first column, so we have here minus 4. This element M22, second row, second column deleted, so this element turns out to be 2. And M23, second row, third column deleted, so this is 1. Then M31 will be equal to minus 20. M32 will be equal to minus 1, minus 12, which is minus 13. And M33 will be equal to 5. So this way we have found the minors. Now when you find out the cofactors, you know the cofactors of these elements will change their signs. So this will remain the same, 11. A12 will become minus 6. A13 will remain same. Likewise, when you find out A21, this sign will change. A22 will remain same. A23 will have its sign changed. Likewise, A31 is minus 20. A32, this element will change its sign. And finally A33, which is equal to 5. So here you can see these are the cofactors which have their signs opposite to those of corresponding minors. Now here we have directly calculated. You can always write down a determinant like this and then evaluate its value. Or you can directly write down this way. So next we are discussing question number 3. I will write down the question here. The question says using cofactors of elements of second row, evaluate the determinant which is given by this expression. Second row is 2, 0, 1, third row is 1, 2, 3. Okay, now here using cofactors of elements of second row. Second row cofactors we have to find out. So this is the second row. When we find out the cofactors of these elements will change their signs. Alright, so if we do the question directly, the determinant second row elements A21 multiplied by its cofactor plus A22 multiplied by its cofactor plus A23 multiplied by its cofactor. This is the value of the determinant. So A21 is 2, A22 is 0, A23 is 1. So these elements is what we have written. Now find out the cofactor. Cofactor, if you want to try out, you can try out here in graph. This means delete second row and the first column. So you have determinant of 3, 2, 8, 3. Now here every time it is not necessary to write down here -1 to the power 2 plus 3. You know the sum of subscripts is odd, so this will be negative. So you can calculate here 9 minus 16, which is equal to positive 7. So that value is positive 7. Then A22, although it is being multiplied by 0, but still we'll find it out. A22, here sum of subscripts is odd, so the determinant will not change its sign. And which is this determinant? Deleting second row, second column, the elements that we have are these. So we get 15 minus 8, which is equal to 7. So 0 multiplied by 7. See, what I am writing here can be directly written here also, or you can even mentally calculate. Now A23, it is sum of subscripts is odd, so negative sign. Deleting second row and third column, we have 5, 1, 3, 2, which gives us minus of 10 minus 3, which is minus 7. So here is minus 7. Now multiply 14, this value is 0, minus 7 equal to 7. So we know the value of the determinant is positive 7.